Thank you. So basically what we are studying is circular motion. What is circular motion? It is the motion of a particle
Motion
along a
along a
circular
circular
path.
path.
And if I draw a circle, always remember the circle, if the particle is moving along this circle in the direction of velocity at any point is always tangential to the circle. Is this clear, guys? The second point, I think it's pretty much clear. Always remember it is tangential. And tangent is always perpendicular to the radial direction. Yes or no? Third, circular motion is an accelerated motion. Why is it an accelerated motion? Can anyone tell me why is circular motion an accelerated motion? Because
It will need a push, and then as it's going around, it's having a change of direction.
exactly because acceleration is what? Because the direction of velocity is changing.
Sir, small doubt, sir.
Yeah.
Normally, acceleration means this one, some sort of push up, right?
So here also this thing is trying, some force is trying to pull it towards the center. That is called as the
Right.
centripetal force. We'll come to the force aspect later on.
No, sir. I'm asking about acceleration. In general life, it means some sort of push, right?
Not necessarily push or pull. It can be acceleration means some force has been applied.
Yeah, that's what I'm trying to say.
So here also it will be pulled towards the center.
That
Okay?
is acceleration over here. Okay.
That is force. This force is providing the acceleration.
Then, sir, where is acceleration over here?
Acceleration, अभी मैं वो भी बताऊंगा. Acceleration, there are three different types of acceleration. There is a centripetal acceleration, a tangential acceleration, and alpha as well. So अभी बाद में बात करेंगे सब. Tension मत ले. अभी whatever I am writing is basically the common points which you need to remember. We'll come back to
Okay.
all the kinematical aspect as well as the dynamics aspect. Don't worry. So it is an accelerated motion because the direction of velocity is changing at every instant of time. That's why it's an
Okay.
accelerated motion. Always along the tangential path. Acha. Based on the magnitude of a velocity vector. Based on the magnitude of a velocity vector. That is, what is the magnitude of velocity? Known as, the magnitude of velocity is known as basically speed. Okay. So based on the
Yes.
speed of the object, based on a speed of the object, the circular motion can be classified in two types. Can be categorized as, first, what do you mean by this?
Sir, a small doubt.
Yes.
Velocity vector and speed vector are both different, or does
Speed is a
something like speed
scalar
vector?
quantity. Speed is a scalar quantity. Velocity is a vector quantity. If you give speed
So
a
speed
certain
vector does
direction,
not exist.
speed vector does not exist. Velocity
Okay.
exists. The uniform circular motion, also called as UCM. This is basically when the magnitude of a velocity, or basically, you know what, the speed is. So whenever the speed is constant, then it's a uniform circular motion. Okay. You can either write that
Yep.
magnitude of velocity is constant or speed. So write like this. Or second part is basically non-uniform circular motion.
When
And
speed is not constant.
exactly, it keeps on changing.
So basically an oval shape
But
sort of thingy.
no. Will be circular path only.
Oh wait, never mind. I got it. Yes, sir, I got it. But if there is no more force, then it will start slowing down. That kind of scenario, right?
Yeah, there will be always a force acting.
No, sir. Like if the force is like if the force stops acting, then
The
in that
particle will
scenario the
no longer move in a circular path. If we're talking about the centripetal force, if that force stops acting, then the particle will no longer be moving in a circular path. Okay, we'll talk about that force later. अभी वो आने तो दे,
yes,
पहले तो first you studied VUAT, right, and then you studied force, right?
yes,
So we'll discuss all the angular parameters of motion. Chalo, I hope everyone has written till here, right? Shall we start? Angular parameters
yes,
for circular motion. First angular parameter is basically called as angular position. What is angular position? For example, suppose guys, there is this circular path and there is this object which is at, let's say, this particular position. Okay, hello. Let's say the
Yes.
object is at this particular position. So always remember, in the case of circular motion, how do you give the position of an object? If it's like, suppose if you have chosen a reference point, let's say you have chosen a reference frame like this. What is this? This is basically your reference frame. So you choose some positive and negative x-axis like that, right? Yes or no? If you will choose a frame plus x plus y minus x minus y, so basically you will choose one axis from which you will be taking the angle, measuring the angle, and always try to measure those angles clockwise. Oh, sorry, anti-clockwise. So from here, can you see this angle is called as the angle subtended by the object at the center of the circular path with respect to the chosen frame is basically called as is the angular position. So is the angular position clear, guys? Is this angle clear? Generally,
Yes.
what does the convention says? Convention says that anti-clockwise is positive and clockwise is negative. This is what we say, and this is the first convention. And the second convention, angle to be measured from positive x. This is generally we follow, but it is not necessary. You should always follow this, right? You can always follow a different angle as well. For example, suppose whenever it is in the first quadrant, then it is easier for you to define, right? Hello, guys. The object is over here in the first quadrant, then theta is between 0 and 90 degree. Yes or no? Then it is easier for you to define. Yes or no? First quadrant. Any doubt? First quadrant.
No, sir.
Everyone knows how to define it, right? If the object is in second quadrant, then how will you define according to this convention? According to this convention, if suppose the object is over here, theta. Then what will be the angular position of this object? Will the angular position be theta over here? Will the angular position be theta over here, or will it be pi minus theta plus? Yes or no? Hello guys, is this clear? So this will be
Yes,
the
sir.
angular position. The object is in the second quadrant. So what about in the third quadrant? Suppose if the object is over here and this angle is given theta. So will this be the angular position? So this is anti-clockwise only, no? You said to measure anti-clockwise. So this is also anti-clockwise. Can you see from here to here? Also, you might told to measure from x-axis. So can you see I have measured from x-axis? Then this be the angle. The angular position will be like this from here to here. Always measured from the positive x-axis. According to this convention, but not necessary. Needed. Is this clear? Is this clear, guys? We don't need this convention from here to here. This is no not, but we don't want it. We just want this convention only, in which the angle can be between 0 and 180. I want this much angle. Automatically, I'll will do the other things as well. Is this clear, guys? Angular position, is this clear? Yes or no? Is angular position clear? Simple hai angle. It's just an angle. Now, let us talk about the next angular parameter, which is called as angular displacement. Now, what is angular displacement? Say over. Uh,
Hi, sir.
hello. It is the angle traversed by the position vector of the particle with respect to the center of the circle is called as angular displacement. It is denoted by delta theta. Okay. So suppose guys, are you writing alongside with me?
Yes, sir.
लिखते रहना है ना, क्योंकि I will not be stopping. साथ साथ में लिखते रहो तो it will be better for you to log in. So suppose guys, let's say at let us suppose guys, this is the center of that circle. Oh, and let's say initially the object is over here at point A, and can you see this is the position vector? Hello guys, can you see this is the position vector from center to this particular point on the circle? Is this the position vector of this point with respect to center? Yes or no? Hello. So let's say at t equals to 0, the angle made by is basically theta. What is theta? Theta is basically the initial angle. After some time, let's say the object moves to this particular point B. Basically, now what will be the position of the center of mass? Sorry, position vector. It will be this. This will be the final position of the center of mass. And the angle from here to here will be how much? Theta f. Okay. So this is basically the angle theta f. What is that? Theta f from here to there. What is theta I? Hello guys, what is theta I?
So theta I is the 90 minus.
So basically theta I is the initial angular position and theta F is the final angular position. So this angle, okay, everyone can see this angle, right? From the initial position to the final position is basically termed as what? Delta theta. But this delta theta will be equal to theta the final position minus initial position, this angle. This is basically the angle swept in certain time t. This angle is called as the angular displacement. Here, please write down. Done?
Yes, sir.
So delta theta is basically theta f minus theta phi. The final angular position minus initial angular position. Now, angular displacement of an object is divided. You can also define this angular displacement, angle in which the position vector sweep out in a given time. Okay, is this clear? Is this clear, guys?
Yes, sir.
Always remember it's a vector quantity. Sir, how can an angle be a vector quantity? It is a vector quantity denoted by delta theta vector for a finite angular displacement delta theta for a finite angular displacement and d theta. You remember differential for a for an infinitesimally small angular. Okay, please remember. If you don't want to write this, you can write this in the next point. It is denoted by delta theta for finite angular displacement and d theta for infinitesimally small angular. Even like it okay. And how is this given by? If it's a vector quantity, then how is it given by? Direction is given by. You can write it as the next point. The direction is given by right hand thumb. Okay. Okay. So suppose what see we are applying the right hand thumb rule over. You need to curl the fingers in such a way that the fingers move or rotate in the direction of motion. Then the thumb points in the direction of d theta or delta theta depending upon whatever is given. For example, suppose I'll be drawing both the things. As you can see, this is the front view and this is the top view. So basically, suppose this is the center. See, this is the center. See, let us say this is your initial angle. You see the particle is over here at t equals to 0, and let's say the particle moves to here. At t equals to 0, the particle is over here, and t equals to t, the particle moves till here. Is this clear, guys? Can you see both the cases? Can you see this angle? This angle is basically your delta theta vector. This is delta theta vector. And where will be theta will be pointing out. Can you see the particle is moving from A to B? The particle is moving from A to B, right? If the particle moves from A to B, then move your fingers from A towards B. So when you move your fingers from A towards B, can you see the thumb is pointing towards you? Is the thumb pointing towards you? Yes or no? So basically here the d theta vector will be, or sorry, delta theta vector will be pointing towards, which is clear. So are you getting my point, guys? So since the particle was going anti-clockwise from A to B, so when you put your thumb over there, so can you see the thumb points in the direction perpendicular to the plane? And always, can you see, from initial position towards final position you are moving it. That is basically the angle called delta. Is this clear? Similarly, suppose one more if I give. suppose guys, again the same thing we will be doing. Let's say this is the center, this is the center. Now I'm going from, let's say, point A to point B. Can you see this angle is very small? Can you see this thing? This angle is basically what your d theta. Yes, sir. So I'm moving from A to B. And this angle is very small, d theta. Can you see I'm moving from A to B, guys? Again. So that implies now I'm moving in clockwise sense. Yes or no, guys? Array, yes or no? Hello. अरे हेलो
Yes, sir.
यस सर
बोलते क्यों नहीं हो
Sir,
सर
sir,
टाइम
sir.
लगता है म्यूट बटन दबाने में
Sir, A to B is clockwise. Again, this was the same thing, front view and this. Can anyone tell me if you apply right hand thumb rule from A to B, where exactly your thumb will be pointing? Will it be pointing into the plane, or will it be pointing towards you, or will it be pointing away from you? Tell me. In this case, will it be pointing towards you, or will it be pointing away from you? Move your finger in the direction of A. Everyone, extend your finger towards A. Suppose you are standing at the center and now you extended your finger towards A. Now curl them towards B. Now tell me where exactly your thumb is pointing of right hand. Is it pointing into the plane or is it pointing out of the plane?
Sir, in.
Into the plane. So basically here the d theta vector will be having a direction into the plane, and similarly, is this clear? If the angle will be very small, this delta theta vector will become d theta vector. Simple. Is this clear? Is this clear? नहीं भी हो तो मैं मान लूंगा.
Sir, clear है, sir.
चलो लिख लो फटाफट. Whenever you're done, just everyone knows this. No? Pi radian is equals to 180 degrees. Yeah.
Yes, sir.
Everyone,
I know.
Yes,
Sir.
sir.
everyone knows this already. We have already बात कर चुके हैं. Dimensionless quantity. If someone asks you dimensional formula, then dimensional formula is none. Why? Because it's a dimensionless quantity. I'm saying dimensionless, not directionless. Okay? There's a huge difference between. Guys, everyone is done with the diagrams?
No, sir, 1 minute.
Are people are you done?
No,
Yes,
sir.
sir.
Just give me a minute.
No, jaldi karo, jaldi karo. Do it fast. Can you see the difference, guys? Clockwise, anti-clockwise. Whenever it is anti-clockwise, it is coming out of the plane. And whenever it is whenever it is anti-clockwise, it is coming out of the plane. And whenever it is clockwise, it is going into the plane. Yes or no? तो थोड़ा सा ध्यान रखना है Then, अरे कितना टाइम है आपके पास?
Sir, I'm done.
Okay. Next, third parameter. First parameter was angular position. Second parameter was angular displacement. Now the third parameter, angular velocity. Can you see everything is going exactly just like we did kinematics, right? Guys, you remember first we discussed position, then we discussed displacement, and after that, we discussed what? Hello? After that, we discussed
Yes.
what? Displacement के बाद we discussed velocity, right?
Yes.
So it's
Sir.
the same thing, same thing. Just now, what is the difference only? What is the only difference? The only difference is basically we are talking in terms of angle.
Oh, okay.
Okay. Final position minus initial position. So can you see the same thing? So now what will be angular velocity? What was velocity? The rate of change of displacement. Angular velocity will be the rate of change of
Angular veloc vector thingy.
angular displacement.
Oh yeah, angular displacement. Sorry, sir.
Displacement called as angular velocity, denoted by
W.
omega. Omega
Oh, omega.
denoted by omega. Greek letter pronounced as omega. Okay. So it is the rate of change of angular displacement. Is this clear?
ये लर्न करना
हाँ याद करना है क्या एक टर्म है ना उनका क्या बोला था मैंने अच्छा याद एक होमवर्क लिख लो all 24 or 25 Greek alphabets.
Sir, but that is not the symbol for omega.
This is also a symbol of omega.
Yes.
मेरे ख्याल से
Wait, what?
this is also A and this is also A if you remember है ना yes or no?
Yeah.
So similarly this is also omega and this is also omega. You understood the same thing? What did you understood? One is in
Sir, I understood world is messed up for using only Greek letters and Latin letters which don't exist.
which don't exist.
But still, it is
Huh?
good.
Huh?
Nothing, sir. Never mind. It is some history thing. It doesn't matter. Let us continue with the chapter
हाँ
topic,
तो ये थोड़ा
whatever we
पढ़
are.
लेना. Sorry.
Yes, sir.
Anyways.
Wait, there are 24 Greek alphabets.
Yes. 24 to 25. I don't know.
Then,
So
sir, what is
guys,
the 25th? This one uncertain alphabet.
huh? I don't know यार. मुझे याद नहीं है बहुत पहले मैंने देखे थे. You can Google
Oh,
it.
okay, no worries.
So basically,
Sure,
angular
sir.
velocity is the rate of change of angular displacement. Now see, suppose Ganesh, क्या हो गया भाई? So guys, suppose there is this object whose initial position is so suppose guys there is this object which is initially over here at t equals to 0 at point A if you want to name it at point A. What is the initial angle? Theta I. And let's say in time t it goes to point B, t equals to t to position theta f, right? So is this the angular displacement delta theta? Yes or no? Yes or no, guys? So here in this
Yes.
case, the average angular velocity. The average angular velocity is basically theta 2 minus theta 1 divided by t2 minus t1. So basically, what is the final? Final is theta f minus theta I divided by delta. Is this clear? So can you see this is nothing but delta theta? So always remember the average angular velocity is nothing but the delta theta by delta. Take, write this please. Similar. If I don't want the average one, if theta f is basically theta plus c theta and theta I is theta. So can you see the angle changes by a very small amount? First write till here, then we'll write that.
अच्छा आज चैप्टर खत्म हो जाएगा
नहीं यार, अभी तो स्टार्ट हुआ है।
वेट ये कौन सा चैप्टर है
NLM, Newton's laws of motion, in your school notebooks.
So
It's
laws of
not
motion.
finishing only. Like since 1 month, I guess we are stuck over here.
Yes sir.
What, Newton's LLM?
Yes, sir.
So first we did NLM, then we did friction, and then we are doing circular motion.
So friction was part of NLM, right?
Yes, it is.
It has so many parts.
And NLM itself has many parts. There is spring forces, there is tension, there is normal reaction, there is club, miscellaneous questions.
So approximately when will you finish this chapter?
Plus 2-3 more lectures.
Okay.
And after this, we'll start with work, power, energy. Okay?
Okay, sir.
So omega average, is this clear, guys, everyone? Is this clear, everyone? This is the average angular velocity. Sir? Hello?
Yes sir.
This is average angular velocity. Can you define instantaneous angular velocity as well? Can anyone tell me what is instantaneous angular velocity? Suppose it's the same circle, but this angle is very small. Can you see this angle? This angle is very small, d theta, and this is covered in how much time? If this is at t equals to t, then this will be at t equals to t plus t. Can you see very small time it is covering this much distance? So in this case, omega instantaneous is this d theta by d. Is this clear? Is this clear, guys? Instantaneous is basically this delta will become d, and if you want to write vector form, you can write vector. The direction of angular velocity is the same as angular displacement. Okay. So this is your angular velocity, instantaneous and average. What is the SI unit? SI unit is basically. Okay. Other units they may give it in terms of RPM. Anyone remembers what is RPM? Rotations or revolutions per minute. Okay. Basically 1 RPM equals to 2 pi radians per Yeah. Hello guys, is it clear?
Yes.
Yes, sir. Yes, sir.
Okay.
RPM is 2 pi rad, which is basically
360 degree.
360 by 60.
Yeah.
360
One
by 60.
revolution or one rotation is basically covering 360 degree, right?
Sir, can I go have water?
Ah, sure, sure, sure.
No, wait, one revolution per minute, right?
When you complete
One
one
RPM
revolution, do you cover 360 degrees at the center of that around which you will revolve?
in 60 seconds, which is like 60 degrees. हाँ ठीक है सर.
Anyway, so I hope this is clear. Now the next thing which we are going to discuss is basically known as the third quantity is done. Now the fourth quantity, angular acceleration, denoted by alpha. Okay, what is alpha defined as? It is the rate of change of Anjay, acceleration, rate of change of
Rate of change of speed per
Velocity.
velocity.
here it will be rate of change of angular velocity. Okay, rate of change of angular velocity. Again, this is also a vector quantity. If the direction of angular acceleration, the direction of angular acceleration and angular velocity omega is say, then magnitude of omega increases. If speed and acceleration are in the same direction, then if the velocity and acceleration are in the same direction, then does the speed increase? Yes or no?
Yes, sir.
Similarly, if the direction of angular velocity and angular acceleration is same, then angular speed will increase. Similarly, if in the opposite direction, then angular speed decreases. Is this clear? Is this clear, guys?
Yes, sir.
How do you give the average angular acceleration? Average angular acceleration is given by delta omega
W.
by delta E. This is the normal form, and the vector form में you will write it as delta omega, and depending upon whether the speed is increasing or decreasing, accordingly alpha. Here, similarly, there will be an instantaneous form as well. Instantaneous angular acceleration. This alpha instantaneous will be equal to omega. Next time I'll not write this alpha instantaneous or alpha average. Whenever I'll write delta omega by delta t, it will be automatically understood it is average, and whenever I'll write d omega by dt, it will be automatically understood it is instantaneous. Is this clear? Is this clear, guys? Are hi Anna.
Yes, sir.
Okay. So alpha is basically this, and magnitude guys, if we talk about, then this alpha has this formula d omega by dt, right? Magnitude wise, if we talk, alpha is d omega by dt, but we know omega is basically d theta by dt. Yes or no? So from here, alpha will be equals to d by dt of d theta alpha will be 2 theta by the double derivative. Okay. Can you see this is the relation of alpha with angular velocity? This is the relation of alpha with angular position. And I can give you one more formula, alpha. Do you remember alpha can be written as d omega by dt? So I can write this as d omega by d theta multiplied by d theta by. Can I write it like this? D theta and d theta will get cancelled out. See, all the formulas are similar. All the formulas are similar in this thing. They might be looking new, but it is similar. See, if you remember, acceleration is basically equals to dv by dt. Acceleration is basically equals to d2x by dt square, and acceleration is equals to v dv by dx. Everyone remembers all these formulas? ये याद है काइनेमेटिक्स?
यस सर याद है पर मैं भूल गया.
याद है पर मैं भूल गया. वेरी गुड. ऐसे ही करना, ऐसे ही करना. So these are your relations, and we'll be seeing these relations very soon. Okay. Please write it down fast. Just tell me, guys, whenever you're done. Just tell me. When is Eid, by the way? Hello?
So July 31st is something.
The 31st.
So 31st, it's the. So 30th, is it a holiday from school? The
For
31st,
school?
from 31st onward it starts.
Okay.
I don't know. I am asking. Okay, me. I'm asking.
So what did you ask? So school anyways we're having a summer break.
Hey, but still, some people generally have this, what do you call extra classes and all, no?
Okay, like that.
Even school will be not taking classes during these days, no? So that's what I'm asking. So I think it's on 31st, right?
Yes.
So, write down, please. Hello. Chalo, done? It's just clear, guys. What just happened? Everything went fine. Now the SI units. Photo खींच लो, लिखो मत. SI unit will be radian per second square Okay, the SI unit will be radian per second square, and the dimensional formula will be equals to m0 l0 p minus 1. Okay, is this clear, guys? Any doubt in this? Any doubt in this, guys? Now write down heading. Write down heading, guys. The relation between linear and angular parameters. Okay. Hello, guys. Hello.
Yes, sir.
No one is saying anything. Sir,
Sir, mic is on.
क्या खा रहा है तू?
It's a chewing gum.
Chewing क्यों खा रहा हो क्लास के दौरान?
Sir, but like,
हम्म?
yes.
खाना नहीं खाया क्या? तेरी मम्मी ने खाना नहीं दिया आज? हम्म? बोलो बोलो. अरे
Sir,
हाँ,
नहीं मैं खा.
खा चुका है ना.
हाँ.
तो फिर ऐसे खाते खाते बोल रहा है. शर्म नहीं आती खाना. Anyways, the first is the relation between linear displacement and angular displacement. So we'll talk about two different cases. We'll talk about one case when the angle is bigger, and one case when the angle is smaller. So suppose, guys, if I talk about this case when the angle is big, I will not draw the whole thing. I will just draw this initial position A and this final position B, and this angle is delta theta. Only look at this part of the circle. Can you see this part of the circle, guys, from A to B? Can you see only this part? Yes or no? Can you see only this part from A to B? Everyone can see this, right?
Yes, sir.
Okay. So if you can see this, now tell me this particular thing, guys. From here to here, from A to B, if I have a straight line, to B. So from A to B, guys, can you see over here there is a line which is not exactly equal to A to B? Arc. Is AB arc and AB line equal? The linear displacement AB line. And we know we can calculate AB arc. Okay. So AB arc can be given by del theta. Do you remember this relation, guys? Do you know this relation? Angle is equals to length of arc upon radius. Yes or no? Everyone knows this, right?
Yes,
Angle
sir.
is basically length of arc upon radius. So I can say AB arc is basically delta theta multiplied by arc. Yes or no? So you can calculate a delta theta multiplied by arc. But will AB line and AB arc be equal in this case? Yes. Tell me this particular thing. Will the AB arc from A to B, this arc, the black one, and this red one, the line, are they the same? Are they having same length or will they have different length? AB arc is not equal to AB length. But if I have the same circle, but I have very small angle, can you see a very small angle, guys, d theta? If this angle is very small, then that implies point A and point B will lie very close to each other. And if I use a line, then can you see in this case, guys? So can you see, guys? Now can you see AB arc and AB length? They are almost the same. For a very small angular displacement, d theta, the length of AB arc and the length of AB line, they are approximately the one and the same. Is this clear, guys? Here, this AB line is basically your linear displacement, and delta theta is basically the angle. Can you see here, when the angle is big, no relation between delta theta and r is there. Although there is one relation which is you will study in solutions of triangle maths. But can you see from here? Here, for a very small angular displacement, AB and AB arc and AB line are equal. So I can write AB arc is basically d theta multiplied by r. So I can write AB is equals to d theta multiplied by r. And can you see I can write even the displacement as d theta multiplied by r. Don't write anything with vector sign. The vector signs shall be removed as of now. So can you see, guys, this small displacement equal to this? Please write it. Tell me to move up or down whenever you want. Is this clear? The relation between linear displacement, instantaneous, or very instantaneous small angular, linear displacement. So basically, the theta multiplied by. Done. So ds is equals to d theta cross r. This is the first relation. Now the second relation. Are you done writing, guys? Till here?
Oh, so 1 minute.
Please write down fast. Done. Everyone done?
Yes, sir.
The next thing which we are going to do is basically the relation between linear velocity and angular velocity. And angular velocity. So now what is the relation between linear velocity and angular velocity? See guys, suppose if you have a circle and let's talk about 2 points which are very close to each other. This is point A and this is point B. And let's say this is the center of the circle. So basically this angle is very small, which is basically how much? D theta, right? Hello guys. Yes or no? Yes or no guys? Yes or no?
Yes, sir.
D theta is very small. So A and B lie very close to each other. Lie वाला वाली. Yes, sir. Since point A and B are lying very close to each other, hello? A and B are lying very close to each other. So basically, what will happen? Hello? What will happen at this point? From A to point B, if I draw the direction of velocity, will the velocity look like this? Will the velocity look like this? Can you see? At point A and B will be very close to each other. So I can say this velocity v vector is basically perpendicular to both. This angle is also 90 degree and this angle is also 90 degree. Yes or no? Since the angle is very small, A and B are lying very close to each other. So can I say both these angles are 90 degree? Yes or no? Almost 90. Or if you still have any, then you can draw it. So basically, this will be the velocity vector. Now, can you see over here from A to B? Will this be your ds vector? The linear displacement from A to B? Yes or no? We just learned about it. The linear displacement from A to B is basically ds vector. Yes or no? From A to B, this red part. Hello.
So,
This
Yes,
is
sir.
basically delta s vector, which we don't want. We want only this ds vector. So now we know this particular thing that A to B line is basically a ds vector. If I say it is at t equals to 0, the object is at A, and t equals to dt, the object is B. So how much is the time taken, guys? How much is the time taken?
T0.
T equals to 0 to t equals to dt. How much is the time taken? Very small time, very small interval, very small distance, right? So can you see over here, this distance ds is nothing but this velocity multiplied by the time interval. Ds is equals to vdt. Yes or no? Yes, then multiplied by the time. I think everyone is clear about this relation. Hai na?
so
Distance is equals to speed multiplied by time. So basically ds will be equals to vdt. Why? Because from A to B, since the distance is very small, A to B, so I am assuming it is constant, right? So that's why I use this formula, ds is equals to v to dt. Enough? So now ds is equals to v dt, and do you remember we already derive a relation between ds, dt and r. So from here, from ds is equals to d theta multiplied by r, I can write that d dt divided by r is basically equals to d theta. Yes or no? Can I write like this, guys? If I can write like this, then my most of the work is done. I can write it like now v by r is basically equals to d theta by dt, and d theta by dt is nothing but omega. So from here, omega is equals to v by r. This like it. Can?
Done, sir.
Okay. So V is equals to R omega. This is very important relation connecting the linear with the angular terms. So if suppose karo if you have any object which is rotating with the angular velocity omega, then you can give the linear velocity of that point. That implies example actually. For example, suppose there is a disk. So I hope everyone is able to see a disk, right?
Yes, sir.
So this is a disk, guys, and now if I say this is the axis of rotation, it is rotating about this axis with the angular velocity omega, and there are 2 points A and B. Okay, A is at a distance of RA, and B is at a distance of RB. This is point A. If I draw the front or top view of this thing, if I draw the top view, then this particular disk is rotating about this center with the angular velocity omega, and there are 2 points A and B. Let's name these points downwards. So A and B. A is at a distance of RA and B is at a distance of RB from the center. So now can you see over here, this particular A is basically having a distance of R and B is having a distance of RB. This is moving in this direction with a linear velocity VA, and this is moving in this direction with a linear velocity VB. Can you note this particular thing VB? I made bigger for B. Can I write VA is equals to RA into omega? Can I write VA is equals to RA into omega? And can I write VB is equals to RB into omega? Can you say this thing, guys? Can you say VA is equals to RA
Yes,
into
yes,
omega
yes, yes.
and VB is equals to RB into omega? Can you say this? We know since RA is less than RB, that implies VB should be greater than, or VA should be less than VB. Yes or no? Let's take it out. That is greater than RA. That implies. So basically, from this particular thing, you will learn two things. Note. First one. First, draw the diagram. Then I'll tell you what two things you have learned in this, and what you will be learning from this.
So the
Done, guys.
answer.
Okay.
Yes, sir.
So the first point is, from here, did you learn this particular thing? The particle which was away from the axis of rotation was moving with a greater linear velocity. Yes, sir?
Greater because it's covering more distance.
Yes, exactly. The particle away from the axis of rotation will always have more linear velocity. Why will it have more linear velocity? Because it has the more distance to travel in the same time, right? Is this clear? The first thing clear? First point clear? The second point is that whenever a body rotates, then all the particles rotates with certain angular rotates with certain angular velocity. Then all the particles on that body revolve in circular motion at the same angular velocity as the whole body. Sir, what do you mean by this? We meant by this, like suppose if there is this body which was rotating with an angular speed omega, then point A is rotating in a circle of radius r. The point A is rotating in a circle of radius r, and point B is rotating in a circle of radius RB. Can you did you understood this particular point? So all the points which are there on the body, they all will be moving in a circular motion, but with different speeds. Is this clear? Is this clear? अरे मेरे भाई, is this clear? Yes,
Yes.
done. Okay. Done? Okay, guys? Are you done?
Okay, so 1 minute. Circular motion. Yes, sir, done.
So last thing. Last thing is basically the relation between angular acceleration alpha and tangential acceleration. A, for this, please leave a page about this much page which you did for linear velocity and all, right? I need that much space again. Okay, guys, you don't need to write all this. No, you can write, take just whatever space which you left for linear velocity and angular velocity, जितना भी space लगा उतना फिर से छोड़ दो. I'll just tell you the relation AT is equals to R into alpha. As of now, just remember this. We'll come back to how to derive the relation between them. But first of all, I need to teach you exactly how many different types of accelerations are there in case of this thing. There is this, and there is one more acceleration. There are basically 3 different accelerations. Is this clear? Hello, guys. Is this clear? So we'll come back to those accelerations a little bit later. Leave that much space which you did for linear velocity and angular velocity. So we'll write heading the kinematical equation for what are the kinematical equations for circular motion? See, guys, do you remember the normal translational motion for linear translational motion? Everyone remembers? Guys, do you remember the equation of motion
Yes,
for
sir.
translational motion? V is equals to U plus AT. This was the first equation. The second equation was? The second equation was? S is equals to UT plus half AT square. The third equation was V square is equals to U square plus 2S. And the fourth equation was basically the fourth equation was delta S nth will be equals to U plus A by 2 into twice of n minus. I think already everyone knows about these equations. Here the terms have their usual meaning. What was V? V was basically the final velocity. U was the initial velocity. T was basically the time. S was basically the displacement in a given time. And A was the acceleration, linear acceleration. And delta S nth was basically the displacement in nth second. Everyone remembers this, right? I hope everyone remembers this. After this, the same equation they exist or similar equations exist for circular motion as well. First equation is omega is equals to omega naught plus alpha t, where omega is the final angular velocity Omega naught is basically the initial angular velocity. Alpha is basically the angular acceleration. T is basically the time. Acha, by the way, do you remember this condition, guys? For translational linear motion when acceleration was constant, right? These equations were only applied when acceleration was constant. But here, these equations will all again be applied only when alpha angular acceleration is okay. So remember this. Na? All these equations are only valid when acceleration is constant. Time. So omega is omega naught plus alpha t. Second equation is angular displacement. So do you remember displacement is equals to ut, so omega naught t plus r alpha. Third equation, omega naught, omega square is equals to omega naught square plus twice of alpha delta theta. And the last equation is delta theta in the nth second will be equals to omega naught plus alpha by 2 twice of alpha. So can you see, guys, it's one and the same thing. Exactly the similar equation basically. I understood which all parameters to be related with what parameters, right? Yes or no? So all these equations will be used when acceleration is constant. If acceleration is a variable, that is, acceleration can be a function of time and acceleration can be a function of position, then how will we relate everything? If A is given as a function of time, then we know this particular thing, velocity is basically dx by dt. Yes or no? So similarly, alpha is given as a function of time, then angular velocity will be d theta by dt. After that, what will be acceleration? Acceleration was basically dv by dt. So here we'll write alpha will be equal to d omega. Are you getting my point, guys? What all things are there? How exactly are we writing? थोड़ा सा सोच समझ के करना है. Please write it. Okay. If acceleration is given as a function of position, if alpha is given as a function of theta, then acceleration is d dv by dx. Okay. Similarly, alpha will be equals to omega d omega by d. So the similar type of formulas are there, guys. I'm not going to explain it much more details. We'll do the questions about this particular thing. In the next class, we'll do some questions. please revise integration differentiation. Everyone, please revise integration differentiation. We'll discuss about in the course, and we'll
So
discuss
कब
that.
रिवाइज करना?
हाँ,
So कब रिवाइज करना?
कल मतलब जब भी next class हो उससे पहले revise करके आना. Okay.
Okay, sir. Okay.
So then we'll be just doing some kinematical questions, and then we'll start with the discussing the acceleration, and then we'll talk about the forces and all. Okay. So in 2 or 3 lectures, circular motion will be complete, and whole NLM chapter will be complete. Okay, guys. Hello.
Okay,
Yeah.
sir.
ठीक है guys.
Yes, sir, sure.
ठीक है. We'll
So
see you
break.
again. हाँ?
Thank you,
हाँ.
sir. Thank you, sir.
नहीं, वैसे भी मुझे
Thank you
बोला
very
गया है
much.
कि सर don't overexert them. It's like if your topic is completed, and if you don't want to
Sir,
start
wait,
any
who said?
management, if your topic is
Sir,
completed,
did they only tell you?
yes,
All.
because someone complained physics sir बहुत पढ़ाते रहते हैं.
Oh.
हम पढ़ाएंगे.
Sir, can you
Sir, from which
request for a
class?
lunch break, sir?
What?
Please. Lunch break. We don't
When?
have a break in the... Sir, none
Sir,
of the
between the
days,
first and
like,
second period.
we can't even eat. Like today, today for bio, Radeep sir asked us to turn on our videos, and I was having food, and then he asked me. So there's no break, right?
अरे तो you should play smart, no? कि when the video is on, you should not have your food and all.
Sir, he asked us to turn on our video from the start. How?
Sir,
do
what
I
she
eat?
was saying is when she
So-
on the video, that time she was eating.
हाँ, तो
So I told him
whenever-
I'm not going to switch on my video because I'm eating, and then he gave me time.
अच्छा.
Yeah. Sir, we're eating in between class. Like,
अच्छा.
everyone.
तो बेटा.
I mean, every teacher knows that.
Yeah, I think
I have a
most of
very
them
good
know it.
suggestion for you people. You have classes from 1:30 to 3:30 first, है ना? Every day.
Sir, I wake up at 1:20.
Sir, one doubt, sir. Are the classes over?
1:20 you wake up.
Sir, class is over,
1:28
right?
I wake up, and then I sit in front of my screen.
Oh my
Sir, wait,
God.
class is over?
Sir, so
Ah,
we
the
have so much homework.
Class is
for
over?
Bio
Yeah,
and
class
all,
is
we have to solve so much.
Sir, can you stop the recording then?
Oh,
Pretty
thank you,
please.
sir. Yes, thank you.
Because
Sir.
everything is being recorded that we are seeing.